All right. Hello, everybody. Congrats on surviving the first lab. So we're here at the second one. All right. So this lab is mostly going to look at earthquake waves. So you should have covered in class P waves, S waves, and surface waves. And surface waves don't come up in this lab, but it's still something to be aware of. This lab is going to look at P wave and S wave arrival times. P waves are sometimes called primary waves because they're the quickest and they arrive first after an earthquake occurs, and they are compressional waves. So sometimes I like to think of like a slinky. If we were to push a slinky, it would compress and then it would expand, like this image is doing here. And then S waves, they're a little slower. Sometimes I hear them called secondary waves because they come second after P waves. And it's a shear force. So they kind of move like a snake. They go up and down. All right. So here's just a little bit of earthquake terminology to help you out. You probably have heard of epicenter before. What you may or may not have heard before is hypocenter, sometimes called a focus. A hypocenter is where an earthquake actually occurs, usually at depth somewhere along a fault plane. And then the epicenter refers to the spot directly above the hypocenter on the surface of the Earth. And so this lab is going to look at a 2007 Alaskan earthquake that had a hypocenter 8 miles down beneath the surface. And it was a magnitude 4.9, so that's pretty big. And the purpose of this lab is to look at data from the P and S waves from this earthquake to try to determine where this earthquake occurred. Okay, so I'll jump right into it. Question 1 is going to be filling out this table mostly. And the way the questions are going to be worded, it's going to say, it's going to want you to fill out the box by box by box. I would kind of recommend maybe copying this box and filling it out in a Google Docs or writing it down, because we're going to need to toggle between this image and this one. And I find it easier just to work with one at a time, but it's up to you. So the letters on the side here, COLA, MCK, PAX, and DOT, they refer to different station names. And then they're the same on this side here, COLA, MCK, PAX, DOT. And this is a seismogram that spit out the seismograph here, all these squiggly lines. And we're going to be calculating the times the P and S waves arrived. We're going to take the difference in that, and then with that we can find a distance. So I did COLA as an example. So I just drew from COLA up here. We see this is the P arrival time. This is when the earthquake would have occurred. I just drew a line straight down, and we have times at the bottom here. So we're going to want times in hours, minutes, seconds. So it can get a little confusing, but we're just going to be careful. So for COLA, I was finding 14, 51, 53 or so. And then for the S wave, I did the same thing. I drew a line straight down. It's looking like it's hitting around 14, 52, 01.5 or so. I did my calculations to 0.5 seconds. If you can do better, I recommend it, but I know it gets a little hard on screen, so I wouldn't sweat it. And then after you have your two times, we can find the SP difference. So S wave minus P wave. Your seconds should be positive. We shouldn't be finding negative numbers, so be careful with that. And it can get a little weird because since we have 01.5 seconds, you're actually going to want to express that as 61.5 seconds when you're subtracting, because it wouldn't make sense to take 1.5 minus 53. So when I did it that way, I got 8.5 seconds. It might also just be easier for you to just count up, whatever works for you. But I found 8.5 seconds for the COLA station. And then once you do this for all of them, you can jump over to this image. And so, yep, for Kola, I found 8.5 seconds. And we want to find where 8.5 seconds fits within here. So this gap here is 8.5 seconds. That's what we're looking for. And then you can come down. That's hitting around 65 kilometers. So the epicentral distance for Kola, I was finding 65 kilometers, give or take. So just be careful with this. Some students are going to want to go like 8.5 here, over and down, and say it's somewhere around 25, but that's not right. That's not big enough. We want the difference between the gaps here. Okay, so the next part looks at earthquake triangulation, which is a pretty cool way of trying to find where the earthquake occurred specifically. So each one of these circles represents a earthquake station, like Kola that we found before. And the radius here is that distance. So if we have multiple stations, we can find a point where they all intersect, and that would be the earthquake epicenter. So let me show you. The lab recommends this website if you don't know where the stations are. You don't need it, but it's here for you. You can type in the stations, although I don't think Kola is on here, but it gives it to you there if you're interested. But we're going to be using this website also given in the Google Sheets to calculate where that earthquake occurred. So you're going to pull it up, it'll look like this, and we can zoom into interior Alaska. And then in the sheets, we have a bunch of different latitudes and longitudes here of the stations. We're only concerned with the first 4, because those are the only 4 we found distances for. So I'll do an example for Kola. We can pick plus station in the upper right corner. We'll get a bar at the bottom. I'll name it Kola. So Kola's latitude 64.7. And then I found the distance was 65 kilometers. Okay, so you just pick enter, and you'll get the station with that radial distance. So you're going to want to do this for all 4 stations, and if you did it correctly, they all will more or less overlap at one point, and that will be where your earthquake occurred. And in the lab, it also asks enter the location of this earthquake, the latitude and longitude. I think the easiest way to do this would just be to pick the plus station again, and you can drag it and put it wherever that earthquake occurred. So if it occurred here, you could drop it here, and it will spit out a latitude and longitude. So I think that's just an easy way to find where that occurred. And then there was, yep, you're going to want to take a screenshot of this when you're done and upload that as well. So don't forget to do that. And then it also is asking, why don't your circles line up perfectly? And there is a reason for that. So I'll let you think about that. You didn't do it wrong. There is kind of a mathematical reason why there might be error in that. And it also asks, why do we need minimum of 3 stations to find it, where an earthquake occurred? So I'll let you think about that as well. And that's all I have for you. So, all right, I'll be here if you have questions.